Yes. Good morning, children. Today we'll start the new chapter in three-dimensional coordinate system. So it is the sixth chapter, direction, cosines, and direction ratios. So what are these direction, cosines, and direction ratios? In the first chapter, like in the fifth chapter, you have learnt about the three-dimensional coordinate system, how the coordinates are and all. Now we'll see. See. Suppose you have two straight lines in a plane. Suppose you have a two-dimensional plane. In that plane, you may have two lines which are either parallel, or you may have two lines which may be either intersecting. So these are the lines. In two-dimensional system, you will have either the lines parallel or intersecting. Suppose they are like this, another line is like this. When you extend it, they will intersect. Somewhere in the plane, they will definitely intersect. Now, in three-dimensional coordinate system, and then in two dimensions, we define slope of a line. What is the slope? We define inclination. We have x-axis, y-axis, and suppose there is a line like this, it will make an angle theta with the positive direction of x-axis, that is called as inclination, and then tan theta is called as the slope. So using the slope, we will find the angle between two lines, and we have the formula angle between two lines as tan theta is equal to mod of m1 minus m2 by 1 plus m1 m2, where m1 and m2 are the slopes of these two lines. So like this, we can find the angle between two lines. Now, in three-dimensional coordinate system, we don't have slope because we will not be defining any inclination. So here we define direction, cosines. So what are these direction, cosines? Now, suppose that you have the coordinate axis, x-axis, y-axis. Suppose that this is x-axis, this is y-axis, and this is z-axis. This is z-axis, which are mutually perpendicular. I am taking only the positive coordinates axis, x-axis, y-axis, and z-axis. It should be in the right-handed system. It should be in the anti-clockwise direction. Sometimes you may take here x, here y, and here z. It should be in this rotation type. So like this, we will take x-axis, y-axis, and z-axis. Now suppose that you have a line like this. Then what you do is draw a line parallel to this line and passing through origin. Draw a line parallel to this line and passing through origin. Now this line will make this line ray. You can consider half ray. So this will make an angle alpha with x-axis, and this will make an angle beta with y-axis, and this will make some angle gamma with z-axis. So consider a line. So to find its direction cosines, we'll draw a line parallel to it and passing through origin. Consider the ray part of it, half line passing through origin like this. Then it makes some angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Then cos alpha is denoted by L. Cos beta is denoted by M. And then cos gamma is denoted by M. So these are the angles. The angles made by the ray with the positive direction of x-axis, y-axis, and z-axis. So consider OA. Okay. So now this cos alpha, cos beta, cos gamma, these three triad L, M, N are called as the direction cosines. L, M, N are called as the direction cosines of this line, and then the direction cosines of the parallel line also. So the direction cosines of parallel lines are equal. They are always equal because they make same angles with the coordinate, positive direction of coordinate axis. So L, M, N are called as the direction cosines of this line. Okay. Now, when you consider the opposite direction of this, in this direction it is making alpha, beta, and gamma. When you take the opposite direction of it, then it makes pi minus alpha with x-axis, pi minus beta with y-axis, and pi minus gamma with z-axis. The same way in the opposite direction will make these angles with the positive direction of coordinate axis. So we take cos pi minus alpha, cos pi minus beta and cos pi minus gamma also as the direction cosines of the same line. So this is one set of direction cosines and this is another set of direction cosines of the same line. So what is cos pi minus alpha? It is minus cos alpha because it is in second quadrant. So minus cos beta and then minus cos gamma are the direction cosines of the same line. So that means minus L minus cos alpha means it is minus L. So minus L minus M minus N are also the direction cosines of the same line. So for a line there are two sets of direction cosines, L, M, N and minus L minus M and minus N. So all this explanation is there on page 134 of your textbook. Page 134 of English medium textbook. In Telugu medium, I don't know the exact page number. So you can just go through, read all this. It is given clearly in your textbook. Okay, now there are, so it is enough if we have if we mention one set of direction cosines, it is enough for us. For any straight line, you can take only one set of direction cosines. Okay, now, so if L, M, N are the direction cosines of a line, if L, M, N are the direction cosines, DCs we write, direction cosines we write in short as DCs. So if L, M, N are the direction cosines of a line, then minus L, minus M, minus N are also the minus L, minus M, minus N are also the direction cosines of the same line. Just now you have seen. So you can now take this direction. Now we'll take the x-axis, y-axis and z-axis. Okay, these are also very important to learn, x, y and z-axis. I'll take only the positive. Now this x-axis is also a line. So it makes what angle with x-axis? It makes 0 degrees angle with x-axis. And then x-axis will make 90 degrees with y-axis. And then x-axis will make 90 degrees with z-axis because they are mutually perpendicular. X-axis, y-axis and z-axis are mutually perpendicular. So x-axis direction cosines. So the direction cosines DCs of x-axis are cos 0 because it makes 0 degrees with positive direction of same x-axis. And then it makes 90 degrees with positive direction of y-axis. And 90 degrees with the positive direction of z-axis. So the direction cosines of x-axis are cos 0, cos 90 and cos 90. Cos 0 is 1, cos 90 is 0, cos 90 is 0. So the direction cosines of x-axis are 1, 0, 0. You must learn these values. Next, in the same way, the direction cosines of y-axis. The direction cosines of y-axis are 0, 1, 0 because it makes 90. Y-axis makes 90 degrees with x-axis and then y-axis makes 0 degrees with y-axis, positive direction of y-axis, and it makes 90 degrees with z-axis like that. So cos 0, cos 90. So these are cos 90, cos 0 and cos 90. In the same way, the direction cosines of z-axis are, z-axis makes 90 degrees with the x-axis and 90 degrees with y-axis and then 0 degrees with the same z-axis. So the direction cosines of z-axis are 0, 0 and 1. By heart these values because cos 0 is 1, it is less. Okay, these values you should by heart. Now next is suppose you have x, y, z in the coordinate plane. Suppose that you have a point P whose coordinates are x, y and z. And then suppose that O is the origin. So suppose that OP distance is R. OP distance is R. And suppose that the direction cosines of OP, that means cos alpha, cos beta, cos gamma are L, M, N, L, M and N. Then you have X as equal to LR and then Y as equal to MR and Z as equal to NR. So when you take the triangle, right angle triangle to XY plane and all, when you derive, you will get like this. So all the derivation is not necessary, just to learn the point. Now I'll write the statement. First you understand. Suppose that you have a point P whose coordinates are x, y, z and whose direction cosines are L, M and N. Then the coordinate and OP distances are. Suppose that P is a point x, y, z, OP distance is R and then it's the OP direction cosines are L, M, N. Then you can write the coordinates as x as LR, y as MR and z as NR. Now next another point here is, suppose that P, X, Y, Z is a point. Then what is OP distance? O is origin. O is 0, 0, 0. Origin. Now what is OP distance formula? It is root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. So that is x square plus y square plus z square under root. So this is OP distance. Okay. So now you have x as LR. Now, so what is L? L is x by R and M is y by R and N is z by R. So if you are given a point P and then if you have to find the direction cosines of that ray OP, then the direction cosines are OP are nothing but x by R, y by R, z by R, where R is equal to OP distance. OP distance, you know the distance formula. So OP distance is R is equal to root of x square plus y square plus z square. Now suppose that there are 2 points in the plane. Suppose that you have, so this is one point you have to learn. Okay, now suppose that you have a line like this which is passing through 2 points x1, y1, z1 and Q is another point x2, y2 and z2. Then how to write its direction cosines? So P is a point x1, y1, z1 and then Q is the point x2, y2, z2 on a straight line. Now to find its direction cosines, you have the formula like this. So the direction cosines, the DCs of the line PQ, are L, M, N. So L is given as x2 minus x1 by R. You can also write x1 minus x2. So y2 minus y1 by R and then z2 minus z1 by R, where R is the distance PQ. R is the distance PQ. What is the distance PQ? Root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So when you are taking x2 minus x1, then you have to take y2 minus y1 and z2 minus z1 here. Otherwise, you can take x1 minus x2, then it is y1 minus y2, z1 minus z2 here. So because L, M, N are the direction cosines, minus L, minus M, minus N are also the direction cosines. So you can subtract in any way, but it should be in that order for all the 3 coordinates. Now we'll write all these points which are needed. So first point is the direction cosines of x-axis are 1, 0, 0. The direction cosines of y-axis are 0, 1, 0 and the direction cosines of z-axis are 0, 0 and 1. 0, 0, 1. Okay, next is, suppose that P is a point. Let P, X, Y, Z be a point. Let P, X, Y, Z be a point in space. Let P, X, Y, Z be a point in space such that OP is equal to R. OP is equal to R. Now, if L, M, N are the direction cosines, if L, M, N are DCs of the ray OP, then X is equal to LR, and then Y is equal to MR, and then Z is equal to NR. So using this, you can just find out the coordinates of the point P. Okay, next point is the reverse of it. Like suppose PXYZ is a point. If PXYZ is a point in space, then the direct only point is given. Then the DCs of AP, then the direction cosines of OP ray are. So if you are given the coordinates, you can just write the direction cosines of OP as X by R, Y by R, and Z by R, where R is equal to root of X square plus Y square plus Z square. Actually, R is OP distance. R is the distance OP. So when you write the distance formula, it is X minus 0 whole square plus Y minus 0 whole square plus Z minus 0 whole square. So that is OP distance, like that. Okay, next is we have an important formula. So what is this LMN? LMN are X by R plus Y by R plus Z by R, no? So, sorry, X by R, Y by R, and then Z by R. So that means L is X by R, M is Y by R, N is Z by R. So we have an important property, that is L square plus M square plus N square is always equal to 1. That means cos square alpha plus cos square beta plus cos square alpha plus cos square beta plus cos square gamma is always equal to 1, where cos alpha, cos beta, cos gamma are the direction cosines of a straight line. So you can easily prove what is L square. Proof is if you find L square plus M square plus N square. What is L square? X square by R square. So this is X square by R square. And M square is Y square by R square. Plus N square. N square is Z square by R square. So when you take LCM, it is X square plus Y square plus Z square by R square. But X square plus Y square plus Z square is nothing but R square. So R square by R square is equal to 1. So this is the proof. Proof is not necessary. Just learn this property, and we'll be applying this property in some problems also. Always when L, M, N are the direction cosines of a straight line, then L square plus M square plus N square is always equal to 1. Now next point is, suppose that you have 2 points x1, y1, z1, x2, y2, z2 in the on a straight line. Then, so next point, okay, fifth point or something, next point, if P x1, y1, z1, x1, y1, z1 and Q x2, y2, z2 are 2 points on a straight line, lying on a straight line, 2 points on a straight line, then the direction cosines of the line PQ, are 2 points on a straight line, then the direction cosines of the line PQ are x2 minus x1 by r, comma y2 minus y1 by r, comma z2 minus z1 by r, where r is equal to root of x2 minus x1. R is actually OP distance, where r is OP distance, PQ. Here P and Q are the points, no? So it is the distance between P and Q. PQ distance, that is root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So these points are very important for us to solve the problems of first exercise. There are 2 exercises in this chapter. So and you will get 7 marks questions from this chapter. So it is very easy. Once you understand, it is very easy. Okay, so this is about the direction cosines. So when you know a point, you can write the direction cosines of OP as x by r, y by r, z by r, where r there is distance OP. When it is PQ points, then it is the distance like this. Okay. Now we'll do the problems. Next we have an property called as Lagrange's identity. That also I'll just give off. You may get that identity for 2 marks. So you can just learn the formula. Lagrange's identity. Lagrange's identity. So you can just note down this formula. That is, suppose that A1, B1, A1, B1, C1 and A2, B2, C2 are 2 triads, 2 numbers, or ordered triads, or ordered pair means you'll have only 2. These are 2 ordered triads of real numbers. Ordered triads of real numbers. This is the statement. So if A1, B1, C1 and A2, B2, C2 are 2 ordered triads of real numbers, then A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1 A2 plus B1 B2 plus C1 C2 whole square is equal to sigma of A1 B2 minus A2 B1 whole square. This is the formula. So just by heart this formula. Actually this means here sigma, here this means it is A1 B2 minus A2 B1 whole square plus the next one will be 1 you replace by 2 and 2 replace by 3. A1 next A2 B3 minus A3 B2 whole square. Next again you replace 2 by 3 and 3 by 1. Then it becomes A3 B1 minus A1 B3 whole square. So like this 1 2 2 3 3 1 1 2 1 3 2 1 3. Yes. So like this is the called as the Lagrange's identity. You learn only till here. This expansion is not necessary. So this is called as the Lagrange's identity. Now we'll do the problems. First problem, if P is a point in space, if P is a point in space such that, if P is a point in space such that OP is equal to root 3, OP is equal to root 3 and OP ray makes angles pi by 3, pi by 4, pi by 3, pi by 4 and pi by 3 with OX, that means with positive direction of x-axis, y-axis and z-axis respectively. Then find the coordinates of P. Then find the coordinates of P. So this is just the first formula. You have x, y, z as equal to LR, MR and NR. So what is given here? You are given OP distance as R. R is equal to root 3. And then L is direction cosines. It is making angles, these 3 angles with the positive direction of x-axis. A positive direction of coordinate axis. So that means the direction cosines, the DCs of OPR L, M, N is equal to cos alpha. What is given? OP is equal to R is given, and then you are given alpha as pi by 3, and then beta as pi by 4, and then gamma as pi by 3. So now L is what? Cos alpha, cos beta and cos gamma. So you just find out the values. Cos of 60 degrees. Pi by 3 means 60 degrees. This is cos of 45 degrees. And pi by 3 is again cos of 60 degrees. Cos 60 is sin 30, that is half. So this is half, 1 by root 2 and 1 by 2. So these are the values of direction cosines. Therefore, x, y, z, the coordinates of P are, we have the formula as x is equal to LR. X is equal to LR, and then y is equal to MR, and then z is equal to NR. You are given R directly, so you will just multiply L, 1 by 2 into root 3, 1 by 2 into root 3, and this is 1 by root 2 into root 3, and then Z is 1 by 2 into root 3. So these are XYZ values. So you will write, therefore the coordinates of P are so finally you will write, therefore the coordinates of P are x, y, z is equal to, what is x? Root 3 by 2. So root 3 by 2, comma, root 3 by root 2, comma, root 3 by 2. So this is your answer. So like this we do the problem. So what is given you find out, and then accordingly you please use the correct formula and then substitute. Okay, next problem. Second problem. Find the DCs of OP. Okay, so here you are given the point P as 2, 3, minus 1. And you must find the direction cosines. So what are the direction cosines? You are given OP coordinates as, those are actually x, y and z in our notation. 2, 3, minus 1. Now we'll find OP distance, that is R. R is root of x square plus y square plus z square. So 2 square plus 3 square, root of 2 square plus 3 square plus minus 1 whole square, that is 9, 14. So this is root 14. So now the direction cosines, DCs of OP are x by r, y by r, and then z by r. So you know all the values, x is 2, y, z, and then r. So just substitute the values. 2 by root 14, 3 by root 14, and then minus 1 by root 14. That's all. This is your answer. Okay. Now next one, you can just you can take down this homework. In exercise 6A, first problem, a line makes angles 90 degrees. These are important for 2 marks, and 30 degrees. So what is to be found? If you can understand, you can easily solve the problems. So a line makes angles with the positive directions of x, y, z axis respectively. Find its direction cosines. So these are alpha, beta and gamma. So the direction cosines are cos alpha, cos beta and cos gamma. You can write LMN is equal to cos alpha, cos beta, cos gamma. So the cos alpha, cos 90 is 0, cos 60 is sin 31 by 2, and then cos 30 degrees is root 3 by 2. So these are the values. So you can just try this problem, write the steps properly. Yeah. Next, third problem also you can take as homework. This is first section, first problem, first section, third problem. So if P root 3, 1, 2 root 3 is a point in space, then find the DCs of AP. Then find the DCs of OP. So just similar to this problem. So the answer here is root 3 by 4, and then 1 by 4, and then root 3 by 2. Okay. And then we'll continue with the problems in the next period.